Hey guys, this is Mr. Muller over at Mandela High School and Media Academy and on the Fremont campus in East Oakland, California. Hopefully this example is going to help you out in going from the reactant side or the left side of an equation to the right side of an equation and figuring out how much of something that you're supposed to have. This is what I call Muller's Muller money analogy. Let's deal with something that we all know. Let's work with coins, okay? I've got listed here 1 penny, 1 nickel, 1 dime, and 1 quarter. If I had to assign a value to each one of these, I totally could. Let's say that the value of a penny is going to be 1, the value of a nickel is 5, the value of a dime is 10, and the value of a quarter is 25. But what I really need to know is 1 what, 5 what, 10 what, and 25 what. What are my units? In chemistry, it is just as important not only to have the number that goes with it, but the unit that goes with it. Okay? So let's pretend that there was some kind of magical periodic table out there that told you all of these kinds of coins that we've got in our currency. Okay? This is what it would look like. The weight of the coin, how much it is actually valued in our society, is going to be listed right there on the bottom. But 1 what? 5 what? What is that unit? Hopefully you're thinking cents. If you're thinking cents, then you're on the right track. Okay? But I'm willing to bet that if you were going to go meet some friends at the movie theater and you were in a hurry, you're not going to dig through your piggy bank and count out 1 penny, 2 penny, 3 penny, 4 penny, right? You're probably going to go for something a bit bigger, something that's a little bit easier to use. What is easier for us to use? Let's think about $1. Okay? Now, if I'm going to switch to dollars, I want to make sure that this number stays the same, because if I don't, I'm going to have to recreate a whole new periodic table and a whole new system that's just going to be incredibly confusing. Okay? So how many pennies will it take us to go from 1 cent to $1? Hopefully you're thinking 100. Let's find out how we can go from 5 cents to $5. How many nickels will we need? Hopefully you're thinking 100. How many dimes will it take us to go from 10 cents to $10? Hopefully, again, you got it, 100. Now let's try this last one. This last one's a teaser. You ready? I'm going from 25 cents to $25. How many quarters will I need? Bam, you got it, 100. Okay? So if we were to go to the bank and we wanted to take 100 quarters, 100 dimes, 100 nickels, or 100 pennies, we're going to end up with that exact same value, except now dealing with dollars instead of dealing with cents. Isn't that a lot easier to use anyway? Hopefully you're thinking, yeah. Okay. Now, at the bank, they're probably going to take those 100 and they're probably going to put them into something that they call a roll. Okay. For this example, I'm not really sure what the bank does, but let's just pretend that 1 roll of coins is equal to 100. Sound good? Okay. Now, how many pennies are there in 1 roll? 100. How many nickels are in 1 roll? 100. How many dimes are in 1 roll? 100. How many quarters are there in 1 roll? 100. Hopefully you're kind of getting the hang of this, is that it doesn't matter what kind of a coin that I've got. If I've got 1 roll of coins, I've always got 100 coins. That number will never change, right? Okay. But the number of coins in 1 roll is always the same, but does that mean that all coins are equal? Nope. Because if I've got 1 penny is worth 1 cent. If I've got a roll of pennies, I've got $1 of it. If I've got 1 nickel, it's worth 5 cents. But if I've got 1 roll, which is 100 nickels, then I've got $5 of it. Isn't $5 worth a whole lot more than $1? Oh yeah. So even though I've got the same number of nickels as I do pennies, nickels are still much more valuable, aren't they? Don't they weigh a whole lot more in our society? Don't we put a lot more value into them? Absolutely. Let me give you another example. Let's say that you needed to put a quarter in the pay meter. If you went to the bank and you took 5 pennies and 2 dimes, you went inside and you exchanged 5 pennies and 2 dimes and you got 1 quarter out of it. Okay? Here are my reactants and here's my product. I'm going to take my 5 pennies and my 2 dimes and I'm going to make a quarter. So I can put that in my parking meter. Okay? If I had a piggy bank with excess pennies, what does excess mean? Excess means extra. So if I've got a piggy bank with unlimited extra amount of pennies, but I've only got 2 dimes, then how many quarters can I possibly make? How many quarters can I get back from the bank? Hopefully now you're thinking that if I've got 2 dimes, I can make 1 quarter. That's what we need to pay attention to. Okay? Let's take a look at this next example. If I had a piggy bank with unlimited number of pennies, but I've got 4 dimes, then how many quarters can I make? Okay, I'm going to look at my equation again. My equation's dealing with 2 dimes. Let's replace that 2 with a 4. If I put this 4 over the 2, what does that equal to? 4 divided by 2 is 2. Okay, so really what I'm doing is I'm doubling that equation out. What is 5 times 2? Okay, and what is 1 times 2 on the right side? I just doubled my entire equation. A lot like having a recipe. If your recipe book tells you how to make 1 cake, but you've got 2 birthday parties to go to this weekend, you're probably going to need to double that recipe to make 2 cakes at one time, right? Okay, same thing happens here. So I just doubled it because I've got now 4 dimes instead of 2, so I'm going to need to have 10 pennies. Let's see if that makes sense. 10 pennies is 10 cents. 4 dimes is 40 cents. 10 plus 40 cents should be equal to 50 cents. What is 2 quarters? 50 cents. Okay, so your answer to this question should be 2 quarters. Let's do another example. If I had a piggy bank with excess pennies, but I had $40 worth in dimes, how many dollars will I end up with in quarters? Let's start off with it. If I've got $40 in dimes, how many dimes must I have? That's kind of crazy. Let's think about it. Well, I know that if I've got 1 roll, I'm already up to $10, right? So really what I'm asking is, how many rolls do I need to have to get to $40? Well, 1 roll gives me $10, so I can divide both sides by $10. 40 divided by 10 gives me 4. So 4 rolls, and each roll gives me $10, so I should be up at $40. So if I've got 4 rolls of dimes now, I can plug that back into the equation again. I've got 4 divided by 2. I need to double my equation. Bam, bam. Am I talking about 2 quarters specifically, or am I talking about 2 rolls of quarters? Okay, those units are important. Because I'm starting off, I found out that I had 4 rolls of dimes, so I'm going to end up with 2 rolls of quarters. You got it. Well, I've got 2 rolls of quarters. How much is each roll of quarters worth? $25. Okay. So if I've got $25 in 1 roll and I've got 2 rolls, I just need to multiply it by 2. And my answer is $50 in quarters. You got it. Okay. Which makes sense because if I've got 4 rolls of dimes, I've got 4 times 10 is $40. $40, but I've got 10 rolls in pennies, so I've got 10 times $1. So $10 plus $40 should give me $50. If you go to the bank and they give you anything less than $50, you need to go back and you need to get your money. Let's do another example. If I had a piggy bank with excess pennies and had $40 in dimes, how many quarters will I end up with? How many individual quarters? This time I'm not talking about dollars. I'm talking about how many quarters I got. Well, I calculated in the last example that I had 2 rolls, didn't I? 4 rolls of dimes will give me 2 rolls of quarters. So how many quarters do I have total then? Well, each roll has given me 100, so I need to double it by 2, and I've got a total of 200 quarters. Seems pretty simple, doesn't it? Now let's work with elements. If I look on the periodic table, the same thing happens. Let's pick hydrogen. This number on bottom is going to tell me its weight. How much is the weight of hydrogen on Earth? So my weight of 1 single hydrogen is 1.01. But 1.01 what? Atomic mass units. Remember way back earlier that the mass of 1 single atom is measured in atomic mass units? Because hydrogen's got 1 proton and 0 neutrons, its overall mass is just 1 atomic mass unit. Okay? Super small. Incredibly small. So just like the penny, the hydrogen is worth 1, but is that easy to work with? Man, could you imagine making a cake and having to sit there and pick out 1 sugar crystal, 2 sugar crystal, 3 sugar crystal, 4 sugar crystal? No, it would take forever. Could you imagine buying a house? 1 penny, 2 penny, 3 penny, 4 penny? Okay, so what I need us to know is that this value, the value of 1 single atom, is so small that it's so difficult to work with. What is the measurement of mass that would be a little bit easier for us to use than AMU? Let's work with the gram. Okay, so just like we asked that question, how many pennies did it take us to get to $1, which is easier to use? How many atoms does it take us to get from 1 atomic mass unit to 1 gram. And it turns out that that number is 6.02 times 10 to the 23rd. Okay. So this number is huge, 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 huge. But what I need you to understand is that that number is so big because it takes so many atoms to get from 1 AMU to 1 gram. Okay. It's like asking how many inches will it take us to get to the moon? Well, an inch is pretty small, so it's going to take us a whole lot of them, right? How many atoms will it take us to get to 1 gram of hydrogen? It's going to take us 6.02 times 10 to the 23rd. Let's do another example. Going from 12 AMU, the mass of one single carbon atom, how many will it take us to get to 12 grams? 6.02 times 10 to the 23rd. Man, catching on? Let's see if we can do this one. 14.01 atomic mass units. How many will it take us to get to 14 grams? 6.02 times 10 to the 23rd. And finally, the last example, hopefully you're able to figure this one out. 6.02 times 10 to the 23rd. Now, instead of taking currency and taking 100 coins and putting into one roll, we're actually going to call this 1 mole. Okay, so I've got 6.02 times 10 to the 23rd atoms will get me from that small, 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 pesky little atom, that small mass for one single small thing, to going to the mass that we can actually use, but we're going to need a group of them, right? So just like it would be easier for you to pay in rolls of pennies, you pull out 1 roll of pennies, you automatically know it's worth $1. If we pull out 1 mole of hydrogen, we automatically know it weighs 1.01 grams. Okay? So how many atoms are there in 1 mole of hydrogen? How many atoms are there in 1 mole of oxygen? Hopefully now you're able to figure it out. 1 mole is always going to be equal to 6.02 times 10 to the 23rd. Just like a roll of coins is always equal to 100. But does that mean that the number of particles, molecules, and atoms in a mole are always the same? So the masses are always the same too? No, that's not the case. Okay? A penny is not worth the same amount as a nickel. So a hydrogen atom is not going to weigh as much as a carbon atom because it's got different numbers of protons and neutrons in it. Okay? So even though I've got the same number of them, I'm not going to have the same weight. 1 mole of hydrogen gives me 1 gram, but 1 mole of carbon gives me about 12 grams. The same example gives me here. 1 roll of pennies will give me $1. 1 roll of nickels will give me $5. I've got the same number, but totally different values. Okay, let's do a chemical reaction. Okay, if I've got 4 hydrogens and 1 carbon, I can create 1 methane molecule, CH4. So this question is asking, if 4 hydrogens react with extra, carbon, then how many CH4 will be produced? You're just going to look at the values. If my coefficient here for H says 4, and my coefficient here for CH4 says 1, so 4 matches up, so I don't need to change anything. My answer is just going to be 1. For every 4 hydrogens I use, I can get 1 CH4 out. If I start with 4.04 grams of hydrogen that react with excess carbon, then how many moles of CH4 will be produced? Let's think about it. If 1 mole of hydrogen gives me 1 gram, then how many moles do I need to get to 4.04 grams? Looks like I'm going to need to multiply something here. What am I going to need to do? Looks like I'm going to need to have 4 moles of hydrogen. If I've got 4 moles of hydrogen, how many CH4 can I create? 1 mole of CH4. Hopefully you're kind of getting the hang of this a little bit. What if I asked you this question? If 4.04 grams of hydrogen react with excess or extra carbon, how many grams of CH4 will be produced? Well, in the last example, so 4 grams of H will be equal to 4 moles of H, which will be able to give us 1 mole of CH4. Well, what is the value of 1 mole of CH4? I've got 1 carbon, and I've got 4 hydrogens, so I'm going to need to take that 1 carbon, take its mass, then take the mass of each hydrogen and multiply it by however many I've got, and my answer is 16.05.